See, Jeremy
Hello.
is let me try a different view here. Jonathan, Juan, George, this is great. I wonder if Rob's not here yet. Okay, he might be coming. Anybody, how's it going with the super warm weather? This is like summer. And I pay my cat to do this, don't be surprised. Yep. He's learned he can jump on me from the desk. He's really enjoying it. Valerie, good to see you. How are you enjoying the warmth today?
It's good. I'm going to go for a walk later. Enjoy it. What's your cat's name?
Cinders.
Sorry?
Cinders.
Oh, that's wonderful.
Yeah, I don't know if you can see very well, but he's got little like white furs on his back. You probably can, right? He didn't have those when he got his name, but it's even more like cindersy, fiery. What's your favorite trail, Valerie?
I mean, I'd love to do Billy Goat again sometime.
Oh, yeah.
That'd be a lot of fun.
Yeah, that's one of my favorites for sure. I have not had a chance to be on part, what was it? Part B, I think is the one that's closed. Is that right?
Yeah, I think so.
Yeah, gorgeous part of country right there. Okay, all right. Well, it's 2 and well, 1 after 2, and we've got a full group here. All right, we're already recording. So welcome everybody to a web crawling practical introduction in Python. I'm Jaren Haber. Really nice to see some familiar faces here. A lot of people that want to learn about the basics of like, how do I get web data? What is this? And I'll just share that this particular data collection challenge has been one that has defined my my academic career to some extent, because I decided that I wanted to study charter school websites or charter school identities, and then I needed to get their websites, and it's just a whole. So what I'm going to try to deliver you today is sort of like the Cliff Notes version. Like if you're going to face a problem like mine, we wanted to study some group of entities online. Here's the shortcuts. There's a lot of stuff out there in web crawling, but I'm going to try to make this very focus on what's useful for people. Okay, and here I go. I'm going to share my screen, and we do have some tech help here. Jonathan is excellent at these things. As far as the crawling stuff, we have Colton, who is I look up to, and George is also here, and Rob should be coming. So these are people I trust when we get to that part where we need another perspective. And with that said, here we go. So yes, you can access these slides. If you go to the repository here, they're in the repository. And you can also, let's see, the file is there. You can also follow it. If you go down a little bit, you can find the, instead of describing it, let me actually show you. Oh, that's not what I wanted. Hold on. Here it is. Yeah, so this is the repository. And you should already have a link to this. If you want to scroll down, there's a ton of resources, but one of them is, oops, refresh. There it is, slides for day 1. And that'll take you right to these Google slides. So you can follow along if you want, look at it later. There's a lot of notes in some of these, so hopefully that's useful for people. Also, I'm a postdoc here at MDI. Delighted to continue for another year. Next year, I'm applying for academic jobs, so pray for me. It's tough out there. Okay, but one thing first. If you can find these slides, or you know what, let me go ahead and put this in the, oh, cat is moving on my desk. Let me put it in the chat, and I actually need to stop my share for that. 1 second. Good, all right, so try this again. In the chat, there is a link there. Please click that. It'll start a server. Here we go. Okay, back on track. And that is a self-contained Python environment with all the packages you need and the code. And sometimes it takes a minute to start up, so click it now, please. It should say binder. You'll see the spinning wheel. After a while, it'll turn to a Jupyter Notebook browser, and then you're on board. Okay, first things second. A land acknowledgement, please. In this DC area, as everywhere in the United States, we are on land that was discovered by the first peoples, not by white people from whom I'm descended. So just to give homage to some of the people that took care of the land for a long time, made it possible for us to be here. I did a little bit of research. That's what I do. The Powhatan Confederacy was one of the big groups, and some of those tribes are gone and some are still around. The Potomac are still around in Virginia, and the Piscataway are still here in Maryland with thousands of members each. And one little fun fact to kind of give this color for you, the Pamunkey and Mattapony tribes are some of the few that are federally recognized, and they're the only ones that are still on the reservation that they contracted to by treaty with the European settlers. And they still, every year on the Wednesday before Thanksgiving, they go to the governor's house in Richmond, Virginia, and deliver to him a gift of food and game and like a piece of pottery. And they powwow with the governor. So these people are still very much around. If you want to see other groups and where they are in space, there's a tool called Native Lands here. And you can just Google it, but it's not a complete list, but it just gives you a sense of who's out there. This is the DC area, obviously. All right, so our agenda for today, getting to the crawling stuff, right? We're going to talk about the digital era, about how to research it, how to scrape without hurting yourself, get deep into a case example from some of my work, and then practice. So my estimate here is we should be done with these slides at like 2:50-ish, and then jump right into Jupyter notebooks and get through a couple of basic things today. And tomorrow we'll get really into the bones of what I think are some of the best contemporary scraping tools. So just to be clear, today and tomorrow are totally different things. Today I'm giving you the basics, the conceptual foundation. Tomorrow is like, what do I need to, like how to use the tools. All right, so jumping in. Yes, we live in digital era. Everything is online. If you want to find a low-income apartment, there's an incredible database at affordablehousingonline.com for all over the country. All 2,000 something housing authorities are on there. Also a great place to get data, which is something some folks in sociology here at GU are working on. If you want to learn about the COVID-19 vaccines, you go to Wikipedia, and there's a ton of information on there. You could search for almost anything on Wikipedia, but I'm like, oh yeah, there's also the mRNA type, and then other inactivated virus type. So if you want to learn about some of the new technology that many of us are getting introduced into our bodies, that's one way to learn about it. If you want to learn about the weather and whether to wear shorts or not, this is yesterday's estimate. How are we doing? The guess was a high of 78. We're doing pretty good. They were spot on. Again, a lot of information and stuff that's essential for living. If you want to learn about the news, you go to an online news site like the New York Times, unless you read the physical paper like I do. We're few and far between these days. All right, so that's just a really short picture. There's a lot online, and it's a little bit of a truism to say that these days. But the question we're approaching here is, how do we research this? So much of social life and a lot more is digital. So how do we get access to this information? Some examples of what have been done in this direction so far. You could take someone's tweets or general social media information and try to detect something like their geography, something Colton has been improving on actually. And for a research cause such as linguistic usage. So who says pop and who says soda? I'm from California. The pop means like something completely different. Whereas apparently if you're from Montana or somewhere over here, that's what you say. Or if you're from the South, say Coke. Interesting. Another thing you can learn about is books. There's like incredible treasure troves of digitized fictional text for one thing, lots and lots of other stuff. But say you take in some digitized fictional text and you find the proportion of words about females. Okay, so there's this line, it's about half, so that kind of makes sense, right? Until you compare the proportion of words about females written by women with that written by men. And it's some noise here, but it's a definite difference in signal, right? Like a quarter versus a half, like that's big. Something else we can learn about, presidential language. So actually in this case, this is what people remember about the presidents based on what they've said and how the media has covered them. So you can take in speeches and ask people to recall them, like what do you remember? And from the election season, shortly before the election, COVID dominated after Trump got COVID, right? But this is all just from I mean, in some sense, you're actually collecting a survey, but those, like, we're actually trying to find the impact of digitized media here and what people remember from that, all those many signals they get. Another thing you could ask is, okay, is all this digitized media? We could ask, how are newspapers, Twitter, and cable TV spreading misinformation? So what we did was identify a couple of myths and get keywords for them and then track those across time. And you see that newspapers talk mostly about racism, and these are myths. So stuff like Biden calling Black people the super predators, which he did not do. Whereas on Twitter, people were focused on attacking Hunter Biden mostly. Okay, so again, just examples of how we can do this. And now, how you can get into this. So a couple of basic steps along the way to developing a web crawling approach that's appropriate for your task. The first thing in our decision hierarchy here, the easiest thing you should always think about is there existing data already? Has somebody already aggregated these tweets or these books or these newspaper articles or whatever? And I can do that without actually having to, deal with websites and all that messiness. If there's already a database, you should use it. And an example here is, well, not just an example, like about a lot of examples. People affiliated with Georgetown have access to library databases, and there are 927 of them, including lots about newspapers, medieval Latin abbreviations, apparently. So check that first. No matter what you're doing, first see if there's something similar. Not always the case, but it's a good thing to be aware of. There's also something called CQP Web. I don't know what that stands for, frankly, but it's used for computational linguistics. And the Georgetown University comp linguistics folks maintain, or at least subscribe to, a lot of these databases. So if you want to learn about language and how it's used and how that changes over time, there's also lots of databases to use on that. So here's kind of a handy decision guide. And it's written for UC Berkeley, so ignore this part. But otherwise, it's the same idea. If there's a resource you can find, you should ask, like, is there a way to access it that's easy, an API? And we'll get into those in a second. But if there is, usually that's the best way to access the existing data. Sometimes you can just download it. That's even easier. But then there's the question of, like, okay, there's no API. Can I download all this stuff myself? You have to check their terms of use, and you might be able to scrape it. But if you're not sure and things aren't listed online, we have librarians for that. Yeah, and I haven't found a guide like this for Georgetown University, but there's a lot of databases on there and a lot of information online. Anyway, all right, so that's existing data for you. The next step for you is to use Web API, and that's might seem a little redundant, but APIs are actually a way to access massive databases, and sometimes those are much bigger than you need, or much bigger than you would want to have in a single download. Like, could you imagine downloading Twitter, like all of Twitter? That would not, you don't need that. That would just be enormous. So, Twitter has an API. You can go in there and say, I want tweets from this date to this date on these topics, and you can still get millions and millions of things to look at. Okay, so an API, usually if there is one, that's your best step. Net of something, a pre-existing database, you can just straight up download. And we'll get to those more in a second, but the next thing you could do, but usually for lots of things, there's no API. So then you have to ask yourself the question, how do I access this? Often there's like a couple of websites or data aggregators or something that you could focus on. So you can exploit their HTML structure, the design, the language of their websites to find the information that you want and design a scraper specifically with that. So to understand that, you need to understand a bit about HTML. So let me give you a brief overview of how the web works here. The web, the internet, the World Wide Web is just a bunch of devices connected together, and they all have data on them. And there's no like amorphous cloud or something. Everything that you download comes from a server most of the time, or if you're using BitTorrent, from a bunch of other devices. But the point is, like, the data exists in some computational, node somewhere. And whether you're using a smartphone or a laptop or a tablet, usually you're requesting data from somewhere and then interpreting that data. So it's just a big old network. The basic idea behind the network is you on your device say, hey, I need to see this website. Can you send me the files so that I can use them to display it? It's a request to a big server like these IBM ones here. And then they would say, most of the time, oh yeah, that's fine. Here you go. Go ahead and parse it. So you'd send a request, they would send a response. And the response is made up of a couple of typical elements here. Usually it's HTML, CSS, and JS. So HTML is like the language in which websites are written. CSS is tools to format it, make it pretty. And JS is for interactive elements, like when you click on something and another menu opens up. And these stand for hypertext, markup language, cascading style sheets, and JavaScript. Don't worry if you don't remember those, but you'll see them all over the place if you keep doing this. Okay, so an example here, how does it work in practice? Pretend you're at my repository, right? You could right click on it from your browser. And I think this is pretty much every browser has this kind of button now. You just click inspect. And what that does is it's you telling your computer, hey, you do so much work presenting these beautiful websites to me. I want to see what's under the hood. What are you actually basing this visual off of? And what you would see is something like this. This is HTML. It's like there's a lot of it, but there's something. These are these div classes where they're saying like here's a chunk of the website. That's what a div is. H1 means a header. So it's the top level header. So I clicked on this thing, web crawling, practical introduction to Python, the title, right? And the your browser knows, okay, this is a main level header. And by the way, here's all this information I have about its style. I know the font size. I know whether it's padded on below or above. And I know the margins. And all of this stuff is explicit, right? So if you really care about that, you could find it. Okay, so that's a little bit about what's under the hood. Another layer here, and just because this is all one story, okay? So APIs are just something in between the device you're using, the computer, and the server. So you're still making a request and getting a response and interpreting it. And this is the same basic loop or interaction. And the API is just saying, okay, here's a database, here's the protocol and rules for how you access it. You can compare this to there's someone at a restaurant and there's actually a kitchen where the stuff is made and you're going to ask for it, but the API is like a waiter. So you're like, oh, here's what I want. And they're like, okay, fill out the terms of service. And then they would bring you your pizza eventually, right? And I didn't make this graph, it came from someone else. Standing on the shoulders of others. All right, so in the case that you can't depend on predictable HTML structure, website structure, structured scraping is not an option. And that's what I call the Wild West. It's a little bit, that's why there was a cowboy in that front level image, right? And it takes quite a bit more work for dealing with this information. And I'm going to try to give you the tools to do that. So a lot of other guides would say like, oh, APIs are great and occasionally want to scrape. I'm going to say, these are great, but sometimes there's no other option other than to do all these things, including find a directory, scrape the URL. So you need to actually find the URLs for these entities, scrape the HTML in all of them, parse it, sort and filter it. So that's quite a workflow, and we're not going to get to all of these. But yeah, maybe, so we're about to jump into an extended case study here, and maybe it's a good time to take a question or two. I see that Juan has his hand raised. Juan, is it on, what you got? What's your question?
Yes, so I've done a little bit of web crawling, and I was actually wondering if in terms of the talk, this is where you would encounter objects such as like Java-backed objects where you have an interface that you're accessing and such. Like it's hard to see like the object behind which you want to extract the information. So it's like, this is like the dimension where you're heading.
That is an informed question. I can see that you've got some experience. I will kind of touch on that as we go. I mean, yes. Okay, so basically we do have to deal with that. So what Juan is saying, everybody else that may be new to this, when you send a request to the server, it sends stuff back, right? If you just take the first thing the server says, sometimes they'll just be like a JavaScript thing. And it's like, it's just gobbledygook until you ask it to clarify what it means by that. So we'll get to that, but yeah, so that's like an essential step. And basically, long story short, Juan, at the end, I'm going to suggest and give you some experience with something called Scrapey. And Scrapey is really good at dealing with JavaScript. And I don't know why, to be honest. Other tools give you a bunch of the junk that's in between, like the stuff that needs more interpretation. But in my experience, at least, Scrapey gives you pretty clean text. So yes, we will deal with that.
Awesome. Yeah, thank you so much. Yeah,
my pleasure.
That's great.
Yeah, great question. Anyone else have a question while we're taking a breath? Okay, well, the raise hand tool is useful, so feel free to use it. And I'll take another break before we get to the practice session for your questions. All right. Oh, Alvaro's hand is raised. Go ahead.
Hi, can you hear me?
I can.
Okay. Well, thank you. My name is Alvaro Camirano. Thank you, Jaren. I just wanted to comment a little bit on what you said about Twitter. I have done some research on mining Twitter data, and what I have found is that sometimes it's better for you to write the web scraping code, like using Beautiful Soup or something else, because the Twitter's API is quite limited. At least the free version I've been using has like a sandbox sample, has like rates, limitations. And for example, right now I'm doing a social policy note using Twitter data. And we had to web scrape, we needed like 2018, 2019, 2020 data. And using the API, we came a bit short on doing on getting data from years back. So sometimes web scraping is like limited by the API's functionalities, such as with Twitter. Besides all the limitation Twitter through its API has.
Interesting. So if I'm hearing you right, it sounds like the main limitation you were encountering with the Twitter API was the volume, like you just needed more information over more periods of time. Is that right?
Yes, that's right. We needed more data for a longer period.
Right. Okay. So, and you weren't able to get that with the API. Even I'm sure you guys looked at having multiple accounts and multiple like.
Right. We needed efficiency, so there was like the limit, the rate limits. Yeah.
Yeah. Interesting.
Like Professor Betsy just said, the geographical limitations are there are a lot of limits regarding Twitter variables. I don't want to discuss much about that, but thank you.
I do have a comment on that really quick. Just so you know, there is a library called Twint that it does web scraping of Twitter behind the hood, and it provides a really elegant interface for web scraping Twitter without going through the API. And I've used that in the past for getting Twitter data that is outside of the date range or without any of the rate limitations of going through the API directly. So if you do want to get Twitter data with web scraping, Twint is a good way to do that.
Interesting. So yeah, thank you for that. That's a great tool to have in mind. The question, it does raise kind of possible ethical questions, or at least things to think about. So the question I would ask is whether Twitter's terms of service allows you to web scrape. And I'm not going to say that if they prohibit it, that it's the worst thing ever to do it. I just think that's a good question to ask. Does anybody know? Alvaro, yeah, go ahead.
Yeah, no, I just wanted to raise my hand again because that's also a question I have, because you know, these websites or these spaces are supposed to have like these robot txt text, or somewhere they are supposed to tell you where you can go and where you cannot go, what data you can web scrape and like that, but almost none do. Like it's really, like you said, the Wild West in terms of what can you do, and whoa, this is public, can I download everything they have or not?
Yeah,
I have other projects that do web scraping, and it's really beginning to be understood.
good. Yeah, thank you. So I mean, it's great to have part of this workshop be accumulating best practices from people, or at least like experiences. So thanks for sharing some of the things that you found lacking in the scraping environment. As far as robots.txt and terms of service, well, I'll touch on that again at the end. Let me just dive into this example here, because I think some of this stuff will make more sense to people once they have a bit more information. And I'll explain some of the some more of the details as we go. All right, so I'm just going to march forward here. So yes, Wild West, charter school websites. That was my focus here. And here are just some examples. And what I invite you to check out is just how, what the layout looks like, without even thinking about HTML. Look at how, where the menu bar is, the self-descriptions, the pictures. And I can just tell you from experience that it is very heterogeneous. as far as structured scraping or scraping specific elements of website design that are predictable. In this situation where I'm trying to scrape 7,000 websites that have nothing to do with each other, for the most part, that's not an option. So I created a workflow. Like I said, you've got to have a directory. So I use the education department public school universe survey. And then I use Google Places API, which I'll talk more about, to get the list of URLs, scraped it with Scrapey cluster, and got website text, as well as some other data that I joined it with later. So that was my web scraping workflow, just very short. Of course, in just a couple of lines, it goes over a lot of the months and years of learning and misery that I encountered to figure out what was the best way to do this. And I will kind of walk you through what some of that looked like as a learning opportunity. Okay, so for URL collection, like I said, I use Google Places API, and this is the kind of stuff that I have access to. So in DC, I'm like, hey, where's a charter school? And it can point you to a lot of them. So if I was to ask Google Places API, like, hey, I know that there's a school named Pioneer Valley Performing Arts. I know that its location is somewhere probably around here. I might even have the right address for it. Can you give me the URL? Most of the time it can. So that's like, okay, that's amazing. That's great. We'll come back to why this is problematic later, but this is the tool that I use at this stage of the project. Okay, the next thing we got to do is, now I've got a URL for everything, to scrape the HTML of each one of those pages that it points to. And packages I've tried for this were Wget, Selenium, Request, and Scrapey. And you'll get practice actually with all of these today and tomorrow. Selenium I left out for time's sake, but it's another really good tool to know about, and I'll tell you why. I made sure across all these different approaches to parse the HTML the same way. And here's how I did it. And this is not perfect, I've since improved on it, but the key element is, hey, here's an HTML file, parse it in Beautiful Soup, extract everything that's got a junk tag, and then get the text. And that's basically the heart of it. And if you're not really familiar with Beautiful Soup or what tags are, don't worry about it. We'll get to that. But this is like, that's the magic right there. I use that in all of these approaches. So this is like a lasso, right? In the Wild West, you go out there, you don't know what you're going to see, but you've got a piece of rope and you can throw it really well, whether at a cactus or a steer, depends on the situation, but at least you've got a tool and it's consistent across situations. So as an example, let's look at this website here for Stony Point Academy, which is a charter school. And they describe themselves as a rigorous preparatory program that's academically rich. Okay, so there's lots of good language there for me to think about as a sociologist. Let's see what it looks like in each of these methods. So the first one, Wget, pretty simple. Like you just Wget URL, and it'll give you the website. Okay, not so simple with all these parameters in here. You'll actually get some practice with this. Here's what they mean. Don't worry about this right now. We'll get to it. But the short version is Wget lets you download all the files that make a website tick to create like a local copy without getting anything above what that website is. So I don't want to scrape the entire internet, just the one website that I point it to and anything below it. So that's pretty cool. That was something that was worth trying. As far as the output, I think was it Alvaro that was pointing to this? I mean, one, sorry. But yeah, without processing the JavaScript further, sort of what the server sends back to you, Wget thinks all this stuff is part of the website. It's really not. Yeah, so I'm not totally sure why that happened, but it was a limitation of that approach. You still get the stuff that's good. If I can figure out a way to parse this, clean all this junk out, that'd be fine. But even with that, it's not a perfect method. You got no data at all for a bunch of them, and for even more of them, you got just one page, not the whole website and all its layers. So yeah, Wget kind of struck out here. Might be a good backup, but not a good first approach. Request was another great idea we had. So we started building this custom web scraper where it's like, find all the links, click them, go to the website. If you find a PDF, download it, doing all this stuff by hand. And if it didn't, it was very slow and it often broke. So we kind of abandoned that approach. And I kind of liken it to trying to reinvent the wheel, or in my case, the flat tire. So that was a months of work that didn't quite pan out, but it was great for learning. The next thing we tried was Selenium. And why did we try Selenium? Well, like we were saying, it's a very handy approach for dealing with modern websites that are JavaScript heavy. So Selenium works by creating a headless browser, which is, well, that's what it looks like. What does that mean? Well, typically, when you're browsing the internet in a web, a web browser, it's got a head. It's got something to actually look at, just like any website. Okay, great. It's easy to read. Your browser is very good at taking HTML and making it easy to read. What would the net be without it? Without that kind of simplicity? A headless browser can actually take the code itself and execute things on it. So you can tell Selenium, hey, click this page over and over again. Go to the next page and imitate a human. So it creates a little browser that you don't actually interact with, but you sort of program in what the browser behavior would be, as if you were actually using it, a browser in person. Okay, so why is that necessary? Why is it important? Well, in our last diagram, it was maybe a little oversimplified. You have requests and you have information coming back to you on your computer. Classically, that's all you need to know. But today, not so much. Often this JavaScript won't just explain itself. Your browser's not going to like magically make sense of it. It's usually something that needs additional conversation with the server. So you make something called JavaScript calls, and then the server is like, oh yeah, by the way, when I said that thing in the JavaScript, here's what I meant. It'll give you more HTML, more CSS. So then you can have some kind of browser experience that's much more fancy. Okay, and that's the short version. All right, as far as what that looked like, a lot cleaner, right? Like, isn't that nice? None of that, whatever the JavaScript or code stuff was before. When we started building another, ground up spider based on Selenium, it was very pretty. The problem was when we tried to scale it and do multi-threading, Selenium didn't like us, and there was no way to make a version that was fast enough to be worth pursuing. So we kicked this one down the road, and then we tried our last approach, Scrapey Cluster, which is like an assemblage of Docker containers. If you know what that means, great. If not, don't worry about it. But it's a pre-cooked environment to make the whole scraping thing move much more smoothly. And it's built on Scrapey, which we will get practice with. But in my case, the same, again, like I mentioned, just as pretty as with Selenium. And it's not using a headless browser, so I don't know why it works that way, but it does. And it also works much better than Wget and didn't require reinventing the wheel. So it worked in 80% of the time, like fully, like we got probably the whole website here. And the rest of the time, at most, we've got at least one page. So, okay, that's pretty good. Okay, so that was just a whirlwind tour of what like scraping the Wild West looks like, right? What kinds of things do I want you to remember from this? Yeah, that it's the Wild West out there. And not to try to rebuild everything yourself. Scrapey is a great tool, so we're going to use it. Why is it great? Because it's flexible and has a lot of online support. It's not that hard to understand. Scrapey Cluster is what I used initially, and it was quite a bit of hacking to get the pieces to fit together. And I'm not a computer scientist. We kind of just had to do our best. But Scrapey is great because you can really fine tune it. And if you want to see some more of this code, well, just keep on this workshop or go to this URL if you want to. It's also on the slides. All right, now, like I promised, getting back to some of these thorny questions. This is like, everyone needs to be aware of ethical issues when it comes to scraping, okay? And it's a pretty complex picture, but I think it's not as dangerous as you might think. There were some high-profile cases of, pardon me for forgetting the man's name, but a guy, I think it was at Harvard University, that ended up getting sued by a big company for scraping their website. I'm forgetting the details, but someone here knows it. So if you know it, put it in the chat. But most of the time, it's actually okay, and I'll tell you why. So how do I know? I mean, this is such a general question here. Can I scrape everything? Like, how do I know something's okay to scrape? If you're at a university, it's usually a good idea to ask your institutional review board. And that's sort of a weird thing to say because usually they only care about human subject data. I think there's a good case to be made for websites and online behavior being human subject data. It comes from people. Are you like directly interacting with somebody? I guess not, but like if you're taking someone's tweets or their blogs, like that's still pretty personal. But IRBs don't really have policies that reflect that. So they don't always know what's best. Oftentimes they'll tell you, it's exempt, do what you want, it's the internet. It's the Wild West, right? But you need to think about it a little bit more. So another good thing to keep in mind is usually you want to follow the terms of service, usually. Now, did I read the terms of service for each one of the 7,000 charter school websites? Absolutely not. Did I scrape the terms of service to figure out what was okay? No, I didn't. Did I follow robots.txt? I also didn't do that. And the reason why is because I'm a social scientist and I care about representativeness, right? Like, I don't want to miss a whole chunk of the internet just because some people tell me not to scrape it. And that's often unkind. But there are other things you can do to make your behavior kind. But most of the time, if you're scraping Twitter or anything, you want to read the terms of service to learn what they say is okay. Okay, but sometimes you have to break it, like I did, probably. What happens if I do? Well, you're not like, okay, there is this big policy law thing called the Computer Fraud and Abuse Act from 30 years ago. It's almost as old as I am. And it basically says like, you shouldn't do something on a website that you're not authorized to do. So like, can you scrape it? Well, it depends on what you're scraping and whether you're authorized to. So like, it might sound like from that law that if you break the terms of service that you could be sued. As it turns out, not really. Big landmark case in web scraping world from 2 years ago, LinkedIn versus HIQ. LinkedIn sued, HIQ is a small firm that was scraping LinkedIn pages to use them for something else. And LinkedIn sued them. They're like, you can't scrape our stuff. Like, yeah, it's public facing, but it's ours and our terms of services don't. And LinkedIn lost. And what that affirmed was that web scraping, things that are facing the public, is a right. And that just blows my mind. So yeah, you're not like legally liable if you stay on the side of what's facing the world. Like if it's out there for everyone to see, you can pretty much scrape it, like period. Okay, so one more caveat here though, to think about, is the whole web in the public domain? Like not necessarily. So there's this useful concept in this book written by Wget called Contextual Privacy. And the idea is this, think about whether the information is supposed to be private in the context in which it's generated and used. If people know and expect that something they post on Twitter will be public, it's a good case that that's public. If they post something on a website and you manage to hack it, and then, or someone else manages to release hacked data that's not public, even though it's publicly released by some hacker, that would be considered private information, right? In that context, because it was created and used in the context of expected privacy. Okay, so that's just something to keep in mind. And this is a whole worm's nest, can of worms. That's the mixing metaphors here. But at least you kind of have a sense for what to watch. All right, so now I can take some more questions, and we're doing good on time. So yeah, if anyone is lost or has a related thought about research or something, chime in. And I've been ignoring the chat, so I'll look at that too. If I can find it. And I'm just going to stop my share for a minute so I can see the chat. Yeah, thanks, Colton. It was Aaron Swartz I was thinking of. He was sued by JSTOR for, gosh, what happened to him? I think he was supposed to pay millions or something. He was facing like a lifetime jail sentence. It was bad. Yeah, okay. Actually, well, I'm going to look at this article later. RV says, what was the second method you outlined before I rejected Selenium? That was requests. That was requests. And you'll get experience with it. It is a low-level library. It's like, you know, request.get web page, and it gives you the HTML of the web page. And then you can beautiful superfy it and do some other stuff. We'll get experience with that. Yes, Betsy says it's hard to get geographical data from Twitter. It's another limitation. Okay, any other thoughts or questions? Ooh, Jeremy, I think I've got something for you. Trying to scrape Google results. Yeah, we're gonna get to a tool for that. Trying to use the Python sleep function. That's a really good point. Okay, so just feel free to add more, Jeremy, but I'll just add that on the topic of the Python sleep function, scraping politely is always a good idea. because for one thing, it's nicer to the server to have a little pause in there. Another thing, it'll prevent you from getting blocked. So if you just send a bunch of rapid fire requests, it'll block you. Is that where you're having trouble with, Jeremy? Oh.
Yeah, if you don't care if I jump on here. So, but it looked like it started to work for me, but then I got empty rows and an empty data frame. So when it did work, I just got an empty row and empty data frame. Another time that I tried scraping from another site, I just got the very last, like the last item of a list for each page. But thanks for having me on here. Hope to learn.
Interesting. Yeah, I'd be interested to hear more about the approach that you're using, and maybe the one we'll practice with today will solve your problem, like ideally. Oh, and thanks, Colton. I didn't know about this this documentary. That sounds really cool.
Yeah, no problem.
All right. Unless there are any other questions or thoughts, I think we can get to code. Oh,
yeah, I had a very short one. So in terms of you mentioned some of the legalities, we should do it contextually, bit by bit, and just really going through like how much of this information could be accessed by anyone versus how many steps I need to take until I get to obviously retrieving this information under a normal access point. Like if I was sitting in my computer, is it taking me a long time to get to the information I want? Like flipping, it's not as easy for me to scrape, but if it's super accessible, then it's likely okay to scrape. The question that I have was the following. In terms of organizing a large project where you, as you did, with schools and you have to do multiple setups and projects, is something such as public school websites and something that is usually government sponsored okay in terms of terms? Like, is there some, because I was trying to check out the ruling, I didn't know that there was a ruling between LinkedIn and HIEC. But in terms of like government programs, is there like a rule of thumb that we can follow as to know if something is okay to scrape or not? Or is I know that it is outside of the scope of this seminar, but still, whatever you can say will be great.
This is a great question to ask, and I'll give part of an answer, and I would love for other folks that have scraping experience to give their opinion. Okay, so since my problem was, here's a field, like here's a universe of organizations. I want to get information on all of them. And yeah, so like state money flow, the federal government, but mostly the state funds these schools. Does that make some difference? Not really. I would actually put charter schools or schools in general, frankly. Well, I'll add a caveat to that, but in the same bucket as like, barbershops or, mom and pop hardware stores. They probably have websites. The website would be a great place to learn about them. But is there anything kind of predictable about them you could draw on? Like, not really. I mean, aside from some of them being hosted by Blackboard.com or like Edleo, I think was another one. Yeah, so unfortunately, like, even though they're government funded at the end of the day, like that doesn't really help.
Okay.
And I'm not sure. So like usually the other part of that is usually when we're talking about things that are government entities, we're talking about a more conventional scraping problem. Like the National Center for Education Statistics has a ton of information on their website. So could I set up like some kind of scrapey thing to just download all that stuff if I wanted to for whatever reason? In that case, there's probably just one terms of service you need to read. It's a much simpler situation. And I would be less inclined to just like ignore all of them. Yeah. One more piece of that. So like if you scrape something and you keep it private on your end, that's like one level of breaking an implicit agreement with the people providing the information. If you scrape it and then you share it with the world, you're much more likely to get sued, because there's a good chance that besides breaking the term of service, you broke the copyright, and you're not legally allowed to share that information. So that's another wrinkle. But what do other people think about like rules of thumb? I mean, the one I can think of is like, if there's an API, use that before scraping, which it sounds like you did in your case. But Other people have suggestions for that?
By the way, thank you for some of the comments on the chat.
Oh, interesting. Yeah, Rob has an interesting thought there. If you need to sign into the website, you need to check the terms of use. If you don't have to sign in, you can scrape freely. I would agree with that. I think it's still nice to, to check it. But if it is public facing and you break terms of use, I think it's probably still okay to even publicly share the data after that, as long as you're sure it's not copyright. Jeremy says Google scrapes the web itself to display search results. Interesting point. And it'll eventually block your IP address and found this page. Custom search. Okay, interesting. That'd be worth looking at. We're actually going to deal with part of this problem in the forthcoming code. But I do see that Alvaro's hand is raised. So Alvaro, what you got?
Yes, first, thanks all of you for the conversation. I have a couple of questions and a comment. The first question is regarding Selenium. I have used it before, and I found that it never reaches a efficiency in terms of downloads to make it like feasible to use it as a tool for web scraping, big data, for example. Have you encountered any any project or case where Selenium is used for big data as a big data solution? The second question is, what do you think about the sites that offer web scraping tools? I know a friend of mine was using a site that's called Octopars or something like that. What it does, it's like an app, a click-based app. You don't need to code anything, and then you just use it freely, or it's premium, or you pay and then you use it and you web scrape any website you want. What do you think about that? And the comment is, I have a the comment is related to the first question, because I have a project that web scrapes online job boards for some countries in Latin America and the Caribbean. And then for some countries, I have these big websites that are asynchronous JavaScript, and I would need to use something like Selenium, and it's just too slow. So what your advice for that would be? Just for people to know, I'll share the project I'm talking about on the chat. Thank you.
Yeah, thank you. Those are great questions, Alvaro. I see Rob saying Selenium wasn't designed as a web scraper. That's true. That's why it's so slow. Yeah, it's worth looking at. Oh, hold on a second. So Selenium can work with different headless browsers. I know there's something called Phantom JS, and then Chrome is another common one, and I think Firefox also works. I couldn't tell you which of those is faster or slower. There's one, Splash, I think, was another one that was supposed to be the faster of the sort. But yeah, the answer, I'm not really sure. I think if I understand this right, I might be behind the times because data science moves fast. But building Selenium into Scrapy and then setting up Scrapy to be what's the word? Concurrent. So you got multiple spiders working at once. And then if you, on top of that, if you've got a big server somewhere and a lot of computational power, you could probably make that pretty fast. But compared to not using Selenium at all, it would just be, it's not a race. Turtle in the hair. So let's see. The other question was about scraping services, and I have looked at those. There was something called Scraping Hub, and I'm not sure I have that name completely right. I think they actually rebranded, but they've got some cool tools. It was called Porsche last I looked. I think they changed it. But you just go in and click on the parts of the website you want to download, and it would actually build a custom scraper for you. And that's worth looking at. Okay, so one sort of aside about that, if you have a GitHub education account, which I always recommend, like I do, you actually have free, what do they call it? A free slot or spider or something for Scraping Hub. And you can actually create one for free and they would run it for you. And it's that might be a trivial amount of work to set up. They make it very easy. Whether it's slow, I don't know. But if you're willing to pay, you can actually save yourself a lot of effort. The other element is if you have access to skilled research apprentices, like I've been amazed by my MBI scholars like George here. I hope you're hearing this, George, that can do some really good work beyond what my capacities are. And that's another way to like get help if you're new to this kind of work. Okay, Scraping Hub is now called Zeit. Thanks, Colton. I think, did I answer your questions, Alvaro? Any remaining pieces there? I wish I had a better answer as far as getting Selenium faster. But I
Yeah, no, thank you. That's great.
Cool. Here's the last thing. I would try Scrapey because the JS in my experience hasn't been a huge problem using that tool, but that may your mileage may vary. Okay, so all right, that was probably like the first half-ish of our time. So let's jump to the last part now. And I'm gonna share my screen again. All right, so let's get our hands dirty. If you go to the repo, you should have the link to that. Wait, you've already done this. We've been over this. Let's see, if your binder hasn't started yet, if it's still got the spinning wheel, just close the window and go back to the repository and start it again. And it should be faster. But if you're there, just get there. Hold on a second here.
It took about 5 minutes for mine to finish loading.
Okay, is anybody having trouble getting their binder thing up? If so, like, yeah, actually, I just want to know, is anybody having trouble? So I know how to scale the response. Betsy it's not working. Have you tried re-clicking the button? So let me actually kind of try to demo this in case it wasn't super clear. All right, so here's my repository. You should just be able to click this launch binder button. And I did try this earlier, but it'll take a minute. And then at some point you'll get a window, and the window looks like, while it's loading, it looks like this. It should come up with something like that. You can't seem to find the binder page you're looking for. Yeah, good idea, RV. I'll send the link. Let me grab that. Yeah, so that link should start the server for you also. Valerie is able to download and clone the repo. That's all you really need. The IPyMB fails to open from the binder. Good to know. But Valerie, you found a workaround, it sounds like. You're okay. Betsy, do you need additional support? You got it? Okay. If anybody else is having trouble, please send a message to Colton or Rob, and because they're really good with this stuff. And Colton,
actually, just so you know, Jaren, I had my binder open and I refreshed the page and it says that it can't seem to find the binder page I was looking for. So it may be if you have it open too long, something happens. I need to.
Yeah, it does time out.
I opened it at the beginning of the meeting.
Okay.
Yeah, that was my problem too. I had it open and then it was, yeah, so.
Yeah, I'm still finding.
Now I'm okay.
It sounds like what I should probably do is actually have people open it halfway through the presentation so it doesn't time out.
Yeah, so now that I reopened it, everything's good.
Yeah.
Okay, that's great. All right, so we are all on this binder page. So let me just check if mine's started. Yep, okay, mine worked too. All right, so let me actually, then it's easy for me to just demo this. So please go to day 1 and go to intro scraping. The first notebook there, not the one that says solutions. That one's for your reference later. And you should get here. And let's see here. Okay, for folks that have camera on, if you've got to that page, give me a sign, give me a wave or a thumbs up or something. Okay, we're all there. If you're not there, again, Colton and Rob are here. Okay, but I guess the best thing is still to share this so we can walk through it together. This is just a review from what we talked about before. Digital era, how do I research it? Okay, great. Now, outline. We're going to talk about APIs first, because that's like, remember from the decision hierarchy, existing data is great. APIs is almost as good. And then we'll get to, we'll actually get to the structured scraping a bit more tomorrow. But a few more basic tools here besides APIs. some URL collection, and hopefully this helped some of you. And then a bit more about Wget, because it does have some cool features. And at the very end, I'll just spotlight this now. Google Places API was what I used. So there's some template code. You can't use it if you don't have an API key. So if you do want to use an API, most of the time you have to request one, and Google isn't free, but they give you credit. So you can apply for one and use it actually quite a bit, up to $200 worth of requests, which is quite a bit. But yeah, it takes time, and for simplicity's sake, I did not, we're not going to assume that you have that. Okay, and here's some vocab in case you need a refresher on some of this stuff. All right, so first off, APIs. Yeah, there's a lot of them. They're mostly free, but not all the time. There's a great one for Wikipedia. There's also a lot of them for Google, including maps, speech to text, and even some machine learning stuff. Okay, by the way, if there is an API, that's pretty much the signal to you as the researcher that they want you to access their websites just from a browser. But most of the time, but the reason they have an API is so that you can design programs, applications that programmatically interface with their data through the API, hence the name. So just, you know, when that's possible. I get it that Twitter API doesn't always give you what you want. In fact, APIs aren't always a perfect solution, but it's the first thing to try, if there is one. All right, so just to see what this looks like, we will try the Google Fact Check API. And right, you guys don't have a key, so you can't really, in fact, even if I click this from inside the binder, it won't work. So don't bother running this code. You know, if you want a key, you can apply for one. There's a link there, as well as some of the documentation and fields and stuff. But anyway, that's what you would do if you had a key. You load it in, and then let's say we want to learn about the infrastructure bill under consideration by Congress and being pushed by the president. You define the query, get the search URL. There's a better way to do this, but this is just simple. And then send something to request, and like, hey, request, like make a GET request. That's what it's called. Get me the HTTP stuff in response for the search URL and the query I'm interested in. And by the way, make it JSON. And this is what you would get. And I didn't run this live, but you know, if I did, this is what would happen. So you can see, like, it's a big dictionary. It's got a claims object, which is a list. And each element of this list is a dictionary, which is itself a claim. Okay, so it's a lot of information. And for example, the first claim review says that each job created would cost $850,000. And what's the claim review? The Washington Post says, there you go, textual rating, their rating of the claim. Is it true? And they say 3 Pinocchios out of 4, meaning they think it's a pretty bold lie. By the way, if you want to see this in real time, there is this page here. And you can just, oh, you know what? Oh yeah, I put that in the notebook so you can see it there. But yeah, you should get the same results. So again, here is the claim. Each job costs $850,000, and the Washington Post says, no, it doesn't hold water. Okay, there's lots of other, actually it was this one. Yeah, lots of other claims in here. So let's make sense of it. So most of these have a date and a claimant. So the person who actually says, you know, who says the thing that they're fact checking. And the date is the date it was said, but these things are not always in there. But these things are. So my challenge for you is, given this big block of text, and yes, you don't have the response object, but you do now, because I turned it into just a plain text object for you. If you just click on this thing, you should now have the response, even without the API. There you go. Okay, now the challenge is, and let me just shrink that for now. Yeah. I want you to print the claimant, text, claim date, and textual rating when you have them. So there's always this one, and there's always this one. But these two you have to be a little more clever about. So you've got the object, and now do it, because this is a lot of working with APIs and web stuff in general is learning how to work with dictionaries, learning what data elements to put where. So here's a Python challenge. Okay, so there you go. I'll give you a couple minutes to do that, and then we'll move on to some other stuff. And if you have questions or aren't clear on what I'm asking you, you can raise your hand or put it in the chat. I will mute myself now so you can get to work. All right, try to finish implementing whatever you got going on there. I'll give you about another minute. Okay, so how did folks resolve this? And by the way, did anybody else hit this issue here, where you've got you try to index text rating? So yeah, what do you have to do? Who got this to work? And you can just put an answer in the chat if you want, or chime in. 0 for claims, Jeremy says. Can you explain that, if you don't mind?
So, well, I haven't done. I guess this is a JSON, the claims text.
Mm-hmm.
This or I mean, how it's set up is with claims. Is that JSON data?
Yeah, JSON is the list of dictionaries. Same idea. Yeah.
So I'm just so what is claims 0, text is 1, claim review 2. I mean, or is claims the key?
Oh, I get what you're saying. Yeah, it's nested. So the first key, yeah, there's a dictionary on the first level where claims is the key, and then this whole thing is the value. Yeah, that's how you would say it. But then like text is a key in the next layer, if that makes sense.
Okay.
So what did you have in mind for the 0? Where would I put that?
I guess right after claims, and another just to the right, to the top of claims, right there. Is that right?
Interesting idea. So what if I put a 0 there? What happens? It doesn't like that. Christian, what you got?
Yeah, I'm just like following along here visually, but I was you had mentioned that you're not gonna get a print for all of the elements, right? Like some of them don't have it, you mentioned?
Right. Yeah. If you just look through here, are there any claims that don't have a date attached?
So
I'm kind of giving you a hint, but yeah, there are.
would they be set to null? Or
Good question.
yeah, because if so, I'd probably put like an if statement, an if condition there in the print.
So what exactly would you say? Like
you mentioned the date is the one that is conditional, right?
right.
I would put a claim if claim open bracket and then the variable name, claim date, and then put not null if not null, or I'm not too sure. I typically code in C++, so I'm not too familiar with Python, but I like know general like programming.
This is great. We're building something. All right, Colton's got a solution for us. Claim.get claimant for claim and response claims.
Yeah, I was just saying that the get method on a dictionary can default to none if the key is not present. Otherwise, what you can say is if key in dictionary, then get by access it by key. But the syntax in Python would be like if claim date in claim. That is how you would check for a key present in a dictionary.
Nice. Okay, that is a missing piece. So let's try it. The get piece is colorful. Let's try the simple way first. Let's just say if there's a claim date in it, and see if that works. Print.
It would be, you don't need claim with the square brackets. It would just be if the string claim date in claim, I believe.
Let's try it. Print claim date. And I'll leave this part out for now because it's, yeah, look at that. That worked. Okay, so now in cases where we have it, is that true? We've got the claim, we got the text, the claim review. Yeah, and there it is, the claim date. So, okay, so that's the basic idea. And then you do something similar for the other piece, claimant. But there's this, I have this one remaining question here, like why is it that I can't do claim review, textual rating? Anybody find a solution to that piece? Why print? Jeremy says. It's just simple, trying to show the output. Aha, Rona got it. Okay. Yeah, so the thing is, if you look at claim review in here, you know, we're kind of being lulled to sleep because of so many dictionaries. We're like, oh yeah, it's a dictionary inside a dictionary inside a dictionary. This one has a list of claims inside the, you know, it's a list of dictionaries. But then when we get to claim review, how many elements are in this list? It's actually just one. There's one element in this list, and it's the dictionary. So you have to index it. You have to slice the list before you can do the what do you call it? Access the elements that are inside of the key value pairs. Let's just. Oh wait, why did I do that? No, not to do that. Does it work? There you go. Oh yeah, I do the same thing with claimant as in here. Nice. Okay, thanks everybody. All right, that was some crowd think. Let's march on though. I want to make sure we get at least can touch on these different pieces before we're done. Okay, the next sort of like building block here is URL collection, and yeah. So there's really, you know, my hack around this basically is like, okay, I've got a directory with school information. I know the name and address of each one of these things. And this is a common situation for all kinds of organizations, whether it's, you know, barbershops or libraries or anything. We live a very organizational life these days. We're born in hospitals and they're put in cemeteries and everything in between. We're in school and there's a website for almost every piece of this puzzle. I should make that into my slides. But okay, so the question is like, how do we get this a URL for all of these things if we don't have one that's clean? And you know, for schools, we don't have one that's clean. So the trick that I use is Google Places API. And if you're doing this at scale, it's just a lot better quality. Doesn't require as much cleaning, tends to be faster, but you need an API key. And there's another problem that I'll tell you in a second, but we'll do the next best thing, which is automated Google search. There's a great package for this. Thank you to Mario Villas, and you can click the links if you want to read more about it. Yeah, it tends to be messier results though, so we need a blacklist of like what domains, you know, third-party website aggregators like Trulia or Yahoo or Yellow Pages that like to say, oh yeah, here's this school here, here's the address. Isn't it great that I just told you that? I'm like, no, I wanted the actual website. So yeah, again, messy data, messy output. Okay, the caveat about Google Maps or Google Places API, it's actually part of the Google Maps sort of like sector of the Googleverse. And they have a terms of service that I completely and fully broke. And I didn't realize this until I did some stupid stuff with scraping and made way too many API requests. And they asked me to kill my to kill my key, just to deauthorize my thing before they would help me get refund. So anyway, the short version is the terms of service has no scraping. And what that means in practice is you can't get data from the API and then store it anywhere else outside. So you could use the API for like, hey, is there a school here? Hey, is this URL I have the right one? That's fine, but you can't actually take the URL from their API. I mean, does it really matter at the end of the day? I'm not really sure, but I got caught. So be aware of these things because you're accountable for them.
Yeah.
All right, so let's do some more with the school URLs thing using our automated Google search and find a charter school in Washington, DC. So we're going to include a pause in there, like someone mentioned, or well, anyway, being polite is always nice. At least 2 seconds, I would say. If you go lower than that, you're walking a fine line. 5 is generous. We're going to stop after 10 results so we don't keep hitting it. And by the way, we're starting with this name and address. Like I said, it came from the federal directory or something similar would have. So you can just execute that and see what it gives you. And so what it's doing is it's saying, hey, Google, what do you got for this school? Give me 10 results. And what do you see here? You can see that there's 6 that have the same prefix, the same domain rather, which is the part before the final slash or the dot, whatever. Well, these are all parts of the domain, but this is the important part. Yeah, so that tells me that, okay, like that's probably the right one. Also, I've never seen this name before. It looks clean. So I think we got a good result there. And I can tell you that even without clicking on it. And then we've got stuff like great schools in Facebook and niche. And I'll just tell you, these are really common ones we want to avoid. If you really want to be sure, it's never a bad idea to actually check your data and voila, it looks like this is the actual website of the school. Whereas if I click on great schools, just to have a sense of what that looks like, a lot of information that they've put together, but it doesn't tell me nearly as much about the culture or the thinking of the school as I'm interested in. All right, so let's try something a little harder to find in that school. Here is another one, Dr. David C. Walker Intermediate School, and it's in San Antonio, Texas, randomly, sort of. So go ahead and do what I did again for this one, and then you can see if it's as good, and then we can think about what we need to do to fix it. I'm giving too much away. I'm going to shut up. But try this challenge, and I'll check in with you in a second.
Hey, Jaren, can I ask a question in the meantime?
Yeah, go ahead. I can't tell who that is, though. Is it Juan?
Juan, yes, sorry.
Go ahead.
I speak a bunch. In terms of alternatives to, for example, calculating times and distances, I know that there's some packages in ArcGIS that could be used using road information to just calculate distances. But I was wondering if you were aware of any type of resource or repository that could be used legally within this context in order to extract like similar information as to what Google has done.
Ooh, for the location of something?
So I have the location. I was mostly trying to like calculate like distances. So we do have information of like, so we've managed to use like OpenStreetMaps and all of these resources to calculate just geocodes, but there's not that much in terms of road information indexed by the amount of cars that use it, such that you could calculate like times to get to somewhere. But I was wondering if while doing your work, you had encountered some type of database that could help in this point and so.
That's interesting. The best stuff I've seen is, I think, uses OpenStreetMaps or maybe even one of the Google APIs. Yeah, it sounds like you're looking for sort of a rich metadata situation. I haven't done that much with that, but Colton has played with geolocation with tweets and that kind of stuff. I think that's pretty hard to do. So if you have suggestions, Colton, you're welcome to shout out.
Yeah, I haven't done like street traffic or like distance by taking rows to places. I've just done latitude and longitude, like geospatial distances between locations. But I would suspect just using a Maps API would be your best bet. But I again don't have really any experience with that.
Okay. Good question. All right, so back to our example. This one's pretty simple. Let's see what it gives me. All right, so what do you think of these results? Somebody just shout your reaction. If I was looking for a school website, how does this look?
Disorganized.
Yeah. Okay, right. There's a lot of different things and they mostly seem like third parties, so not very helpful. All right, so how are we gonna improve this? And I think I'll just give you one example of this. And my answer here is a blacklist. So you've got a bunch of websites we don't care about. It's quite possible that somewhere in there is actually a good one, but it's hard to see it through all the mess. So let's actually take all these websites and put them in a blacklist here, so we're not scraping them. So Google is going to give us its output, and then we're going to remove anything that's not useful for this same school, and then we'll see if we can get what the first quality result looks like. It's a very similar kind of problem, but in this case, we're just looking for the first URL. Okay, in this case, actually, we took a bunch of this stuff we knew wasn't good, and and filtered it out. And then the last one was one that actually seems okay. And if you wanted to, you click on this, and it is actually it looks good. It's pretty spare, but it is a school page within the School of Excellence in Education. That's what often these websites look like. All right, so let's see. Oh yeah, and then the challenge would be to expand the blacklist. Or try a broader search to get this. I think I must have made a mistake here because we just did that. Oh no, it was actually to get a set of 10 results, I think was the challenge. Anyway, we're gonna skip that because we're got 10 minutes left. Let's just jump to Wget, and this is the last part for today. Here's some more information. Wget is like a classic package in shell. It does not belong in this workshop by any conventional means, but it's useful, and I've played with it a lot. And there are some use cases for which this is it's just a great tool. If you're trying just to download a website, get all the files so you can analyze images or look at file relationships or even analyze text, but you want to have something that you can hold on to for a while and get all the pages from a website, most of the time this actually works pretty good. And especially if you're doing more of a hand curated set, you have 10 things, you want to get the whole website. Downloading an entire website via request, you'd actually have to get the URLs for each reference from each page, which takes a little bit more work. So anyway, this one is already built, and it's a great backup for anything else. So let's try it. There's a nice Python wrapper, and it should be in your binders. Oh, look at that. That was fast. So it got us this web page for MDI News on the court website. So we actually got a download. So if you go to your browser here, you should see the same thing I see. Look at that, HTML. To be honest, I'm not sure why my browser doesn't feel like interpreting this. It might be just because of the file suffix, but anyway, you can see that it's HTML, and it actually is the same website as the page itself, which I'll just preview. Looks like this. So okay, so we want to scrape this. It looks like we just did, so that's okay. What we didn't manage to just do was get a nice name. But what if I want something I can I can navigate more easily, or I want to get more of the pages, not just that one page, because you can see here this is just one file. For that, we actually have to use the full feature set of Wget, which is very easy to do in Jupyter Notebook. You just call it in shell. So actually executing a shell command here, using the hash bang, ! Call it what you want. Let's do this again. And again, that was fast. It got us a single file. Let's check out that file. Wow. So just to make sure you know what we're looking at, this is index.html. It's a single HTML file. But Wget is smart enough that even just with one file, I know we're not talking CSS here or anything, it got for us the whole website. So so try clicking around on your end too. Like just try clicking on things and see where this interface begins and ends. Like where can you go using this stolen single file version of a website? I'm just going to click around and see what works. Got a letter from the dean. Can I donate to them? Wow. Can I make a gift? I can't do that. What happens if I? Wow, it even interfaces on my computer. Cool. So what do you notice? What are we not able to see from this simplified version of the website? No one's hit the limits here yet? Well, let me ask it differently. Why do you think, based on what we talked about today, I can't play this video? I keep clicking on the play button. Nothing happens. Yeah, funny situation, Valerie. If you don't have it installed on your shell, you actually probably should do that. It'd be like a sudo apt-get thing. And Colton, yeah, is it installed in the notebook? Oh, he's responding to Jeremy. Okay, well, just in the interest of time, I can't play this video because I don't have it. Isn't that strange? The entire website is kept in one file, which is mind-boggling. But the video needs to be stored in a separate file that's referenced by this thing, or called from the HTML itself, which this does not do. If this was just pointing to something on the open web, it would still work. All right, so anyway, that's pretty cool. So now we've got access to the full set of features for Wget, and if you're using this locally, you probably do need to install it. Yeah, and it wouldn't be a pip install, by the way, because it's not a Python package, the version we're using. We're using the shell version. Okay, so there's all these features, and this is where Wget really shines. You can tell it, hey, like, get me all the files needed. So I can't just see the website. I actually have all the bones it would require for me to host it myself or analyze it separately. Also, let's wait so that we're nice. If it fails, try again. Make me look like a Mozilla browser. Give me a header that doesn't look like a robot. Oh, and I know this is a fine website. Don't bother checking it. And I can run that. And it's going to take a little bit longer. It's honoring robots.txt, which tells it what it can scrape and what it can't, right? So that's good. Also, there's how long? 2 seconds between each request, so it takes a minute. While it's running, you can actually look down here a little bit at some of the other features that Wget can do. Recursive is really nice. That's actually the main tool for going through each of the separate pages within the website. You can tell it, hey, like, just look at the specific URL that I mentioned and anything underneath it, like, you know, school.com/page/whatever, as long as it doesn't go above that to like the parent site. You can make it convert the link so everything works. Run in the background if you want. There's some other stuff, but yeah, this is still running. And let's watch it work. There you go. It's downloading everything required, including the research page. I can probably already click on this. Yeah, there you go. Same page we were looking at before. And it's getting all the WordPress content and plugins. What's down here? Oh, JavaScript too. And that's more organized than I was expecting. All right, so yeah, and then the challenge is, and I think I can ask you to do this in probably 2 minutes. This is going to finish running just momentarily, but you can start to code already. So tried to do download that same website, the McCourt website, and I haven't had any problems getting blocked myself because of the wait period. But download only HTML files. So you're gonna need to look into this a little bit more. What kinds of features would you need to make that happen? From this website and from anything below that. So it's a different page within McCourt about research. I actually know both these people. They're really great. Oh, and look, it's done already. So you just go ahead with that challenge. I'm going to poke around for a minute and see what else I can access from this first download.
Do you know how long Binder will persist our files and how long this work notebook will be available?
Great question. So the beauty of the Binder setup is that that button will work pretty much indefinitely. So anytime you want to go and do this again, you could create a spontaneous Jupyter Notebook server. The downside is it's short-lived, so the answer is not that long as far as like keeping the files that you want. Yeah, you would need to go in here and like, how would you do that? You could download individual files. But probably the best way to do that, if you did want to download all this stuff, would be to open up a terminal from the browser and then like SCP everything, like send it directly to your computer using your IP address. It's not super easy to do, but it's also unlikely that, like, you could just run all this, you could clone this and run it all locally again and get all the same files. So if you wanted to persist the actual like notebooks and stuff, I would suggest Git cloning it. Okay, who got a solution for this part? What's the setting you need to use? Anybody? All right, well, we're at time, so I'm just going to tell you, you just accept HTML files. Whoops. I actually forget what I did wrong here. Is it that? No.
You need the exclamation point in front of the wget.
Oh, brilliant. Thanks, Colton. Let's see if that works.
Yep.
Oh, that was fast. Okay, well, anyway, that's the tool. So we're at time. I will see y'all tomorrow. There's a couple of challenges we didn't get to, and like I said, template code, but you can feel free to play with this and yeah, keep going with it. I think you could always download the notebook and play with it there. But okay, thanks everybody for coming today. It's been really fun for me to share something I've learned so painstakingly, and hopefully this saves you some effort. And I'll see you tomorrow. All right.
Thank you.
Thank you very much, Jaren. Thank you, everyone.
See you, Colton. Bye, everybody.